All right. Hey, everyone. Welcome to the fourth episode of the MEAM Faculty Spotlight Series, which is sponsored by the Penn American Society of Mechanical Engineers. It's been a crazy semester. COVID is winding down. I have the vaccine, I'm sure, as well as Jason and Joe Valdez joining us here today. And very exciting news with Penn saying that we're going to have in-person classes next semester. So that's very exciting. And we're going to be doing these faculty spotlights. I think we have another one to wrap up the semester after this one. And we're going to be continuing this next semester. And what we're doing is we're just highlighting professors and faculty like Joe, who's joining us today, professors that you've taken classes with or done research with. And we had the pleasure of interviewing Professor Dustin Roberts, Jordan Rainey, and Igor Bargatin so far. And yeah, really excited to get started. I'm going to pass it off to my colleague Jason, who's joined with us today.
Yeah, so thanks for that intro, Adam. As he mentioned, my name's Jason. I'm from Yardley, Pennsylvania originally. I'm joined by my peer Adam, who's from Atlanta, Georgia originally. And we're both mechanical engineering and applied mechanics majors at Penn, wrapping up right now our junior year at Penn. So getting ready for the fourth and final year of our undergrad education. And one of the things that we as Penn students are most grateful for really is the ability to learn from and engage closely with the world-renowned faculty at this university. So we've been really fortunate to get exposed to a wide variety of fascinating and practically useful concepts across all of engineering as a whole, really. So today we delve more into actually a favorite discipline among many students, and that is machining and more of the hands-on side of mechanical engineering, really. So we'll be chatting about it with somebody today actually who's not only a master of the mill, but also a teacher and a mentor to all of us in MEAM. So without further ado, I'd love to introduce Mr. Joe Valdez, an instrumentation technician within the MEAM department at Penn, who was willing to take the time out of his very busy schedule to talk with us today. Adam and I have taken MEAM 201 with him, but we've always been curious to learn a little bit about him outside the scope of just that class. And so we're excited to do that today. So Joe, without further ado, welcome. Thank you for being here. And we look forward to learning more from you.
Well, I just want to thank you guys for reaching out to me. And as you know, and you can see the smile on my face, I absolutely love it here in MEAM, Mechanical Engineering at SEAS. And my biggest joy is working with you guys, the students in MEAM, and solving problems. So and I'm honored to be part of this video, and just to be, how do I say it? Just the faculty members you mentioned, to just be asked to join in with the faculty, it's just an amazing thing. So I am completely honored and I'm floored.
Well, we're very excited as well. So why don't we go ahead and get started? We've known you through Mechanical Engineering 201, and we know your title, and we've seen you in the precision machining lab as well as throughout town building. But we'd love to learn about a little bit of your background, like where you're from, and maybe as well like a fun fact that people may not know about you. So something that us or our peers may not know about you.
All right, well, that's a tough one. So I'm originally I'm still live in New Jersey. So I was born just outside of Philadelphia in 1960. So I've always lived in the area. And you can see I'm in the SEAS building right now, but I'm in an area where I can have my mask off because we can eat in this area. So I should say that.
Right.
Because we are in a time of COVID. And I figured this would be the perfect spot. But about me is, I see myself more as a problem solver, more than just someone who does manufacturing, because being in engineering is just a whole new, for me, being in engineering, it was completely new from what I was used to in outside industry. Basically, you're tasked with producing widgets for a company, and they do that for a profit. But here, it's completely different. We're doing this because we're here trying to educate students that are coming up that have a vested interest in engineering. So it's just the perfect role for me because I like to help people. I'm a people person to begin with. It's, but before I get long-winded, besides manufacturing, my
Yeah.
biggest love is anthropology. So,
Really?
yeah, I like historical archaeology. I like to study cultures, how cultures migrated, you know, over time. And it's, I don't know, if I could turn back the pages of time, I would have probably been a historical archaeologist or something of that nature.
That is awesome. And for the viewers that are tuning in, if you don't know, Joe is also enrolled as a student, and we're going to dive into that a little bit later. But thank you for bringing that up. It's something I'm really excited about learning about as well. But moving on to the next question, I'm wondering, I've been, staying at my desk. I'm fortunate to be able to go to the town building for one of my lab classes in person, which has been awesome. But we're curious to see how you've been spending your time outside of Penn during the COVID pandemic.
Well, during this time, for the first 6 months, we were working remotely. So that was a little bit difficult at first because in manufacturing, we're out of our element. I don't have students in my home or milling machines or lathes or drill presses. So what we did at first in MEAM 201 to finish out the semester, we still held Zoom meetings and office hours. So the students were tasked with developing their prints for manufacture. And then what I did along with my colleagues was meet with students at night. We would hold office hours, which was a complete blast. It made my day. And we would just go over to prints and we would critique them and go back and forth and just talk about engineering and some of the problems they're having with trying to draw prints at home with their laptops, not having that computer power of Penn, So that's kind of how the first 6 months went. The second 6 months, it was kind of like getting acclimated back into Penn. So we were coming back into the facility and working a couple nights a week. For me, it was at night because I spend most of my time at night. So, and that brings us up to about now. So.
Yeah, well, having taken MEAM 201 myself, I can definitely speak to the fact that it is great that you got that in-person component back because I feel for those people who had a couple months removed and may not have been able to make their heat engines, at least not on the, original schedule. So that's awesome that you were able to, push for MEAM 201 to be one of the classes that gets prioritized to, return to in-person activities so that those people are able to make their heat engines and maybe wind up like me and keep it at their desk even when they're home after COVID hits. One thing I'm curious to hear a little more about was that you talked about how in your career path you were kind of in industry before, but then now you really, I guess, define or you consider yourself as a problem solver above, just a typical machinist. Can you speak a little bit to the kinds of problems that either you solve or that you kind of mentor students as they're solving, whether that be I guess the pandemic is a problem that had to get solved, how to, machine a Stirling engine and specific components of that are problems that must get solved. But I'm curious, I guess, especially outside the realm of the context in which we know you, like what other kinds of problems that we might not know about are you solving regularly in or out of your work with Penn?
Well, actually, it's just a great question. And it can be wide ranging because as I always used to tell students, you have to have a lot of irons in the fire, and one of them you would find your true path, right? So when I say problem solving, just walking from A to B, down a street, it's be ready for anything. And for me, that means a great example would be if a student comes, and I'll go back to the machine shop. So I don't see the machine shop as a machine shop. I see it as a toolbox. So if I have an idea for something that needs to be manufactured, I automatically think, what do I have in my toolbox? I have a mill, I have a lathe, I have a drill press, I have plenty of tools at my disposal. So in life alone, I set up my home life as a toolbox. Like if I have an idea for, well, what do I want to do this weekend? Where do I want to venture? Do I want to take my kids on an adventure this weekend? So I'll scout out the area as an historian, and then I'm kind of a narrator as we drive. So I'm sure my kids love that, but that's on a personal note. But that's kind of how I see everything that I do in life. It's like, as you as an engineer, well, if I'm looking for a job, all right, well, what avenues can I look to get a job? So that's solving a problem, you know? Um, Strangely enough, when I first got hired here at Penn, I tried to apply on an online site and it wouldn't send. So I called the office manager, Sue Waddington, and I'll just put her name out there. She's a wonderful person. And I said, I'm trying to apply for the job and it won't let me send. And she goes, no wonder I'm not getting any applications. So they weren't getting any applications and I was the first one to call.
Wow.
So do the unexpected, solve the problem. Everything is an issue, For me this year, it's been technology, Zoom. I didn't own a smartphone until COVID started. And now my wife can't get me off of it. But anyway, I hope that answered that. It's about everything, and that's where anthropology comes in.
Yeah, well, I think that's a really interesting analogy you make to the toolkit, because some students, at times myself included, kind of view machining as like, you're given the blueprints, you're given the instructions, you follow them. But that's really a naive interpretation. And at first, obviously, you do need to learn the basics, but then I think what a lot of students have to strive for is to learn from people like you, to wind up similar to people like you, in the sense that we learn from these experiences and have these toolkits that we're able to kind of like look at an individual problem and think like, okay, what can I pull from, rather than just always resorting to the same like predetermined script or something, because that's not how it works in real life in machining or in like solving problems with a pen and paper. Like, it's great to be adaptive and to learn skills first and then be ready to apply them second. So, and then
Yeah, I can't help but also relate to this. I ran cross country in high school, and my coach always said, Adam, you have to be comfortable being uncomfortable. Because when you're running a mile, like you're running a 5K, you're at your worst stage, right? You're heaving and you're trying to get to the finish line. In a way, like I relate to a lot. Like the toolkit that I've developed through the engineering curriculum at Penn is a lot of times uncomfortable. Like the problem sets, the machining, and thank God MEAM 201 was really open-ended, because I was able to be uncomfortable. And so I relate to that so much. And I think it's amazing that you kind of framed it in that way. And every person leaving Penn walks away with that toolkit. And they're going to be comfortable being uncomfortable, whether they're working at, a company like Tesla, working on vehicles, or even doing something like going to law school or going to med school. Penn engineers do amazing things. And it's such a wide range of activities that they go into. But they learn this core principle that you've alluded to, and that's problem solving.
And I'm happy I was just gonna say, I'm happy that both of you mentioned not just the engineering applications of problem solving, whether it be like running cross country, or Joe, you talked about your interest in anthropology, that there are these skills that we as engineers can learn, or my friend in political science can learn. And at the end of the day, human beings just have to have this fundamental ability for problem solving. So Joe, it sounded like you were saying something. I'm curious to hear what you were starting to say, but I'm also curious to talk more about your interest in anthropology and the other classes you take at Penn, just because that's an interesting thing that most students like me wouldn't expect from faculty who we learn from, that they too are learning quite literally in classrooms with other students. So So again, if you were starting to say something, I'm happy to hear it, but I'm also eager to hear about your experience as a student, just like we are.
Sure. There is so much to talk about as an older person in the classrooms. But I was going to say, just speaking of engineers, right? Engineering alone. Uh, and I may have the dates wrong, but back in the 1950s and 60s, the CEOs of companies were not masters in business. They were
Yeah.
engineers. And and that's one thing, and I just would, students that go to Wharton, nothing wrong with Wharton, of course, but I
Yeah, we
think
don't
the
like them.
best CEOs be engineers because I feel that they would, they're passionate about what they develop. And it wouldn't be just engineering to fail. It would be engineering to last so we can use our money to buy things we really want to buy. I won't go down that rabbit hole, but engineers,
I,
CEOs.
I just want to follow up on that specifically because I can really relate. And Adam had mentioned earlier that students may wind up at places, you know, from Tesla to like going to law school or whatever. But speaking to the Tesla point specifically, I was doing research recently on Elon Musk, and he said in an interview that I'm sure anybody listening is familiar with Elon Musk, you know, founder of Tesla and SpaceX and several other companies. But he said recently that um, that he didn't start a business because he was a businessman. He started a business because he loved engineering, but felt like if he didn't have his own business, then he would be too restricted from doing the engineering he wanted to. So at the end of the
Yes.
day, even his becoming a businessman was just to free up his engineer side, you know? And I think to some extent, that's something we should all strive for, you know, like letting our curiosity as an engineer, our desire to, you know, delve into the unknown and build things that haven't been built before, to let that drive wherever we go, even if we wind up, you know, on the business side of things. Like Adam here can speak to his engineering entrepreneurship minor, for example. A lot of us have skills across multiple areas, and I think it's just important to let the passion for engineering really motivate everything that comes after. So yeah, I guess just so that we hit some of these other topics too, I am curious, Joe, to hear about your other experiences as a student at Penn. So you've talked about your anthropology interest. I have friends who have taken classes with you actually in anthropology. One of them took a class with you in acting, which for anybody listening, Penn has some great acting classes. I didn't know until recently. So we're curious to hear more about that.
Yeah, so that's the blessing of being a staff member at Penn. And they encourage that here at Penn. So, and there's no better way to get connected to students than to sit with them in a classroom and have to, you know, rely on each other to work out our problems, you know, get the papers delivered, work on, well, especially in acting class, because, you know, that was, if you're planning to, anybody who's planning to come to Penn, take the acting classes. There's so much more involved in acting, and it just increase your ability to be just a better person in daily life. So that's my plug for acting. But you got to have some fun at Penn. You can't just do engineering or, you know, complete studies. It's not all about work. It's about having fun too. But I guess that pretty much says it. So I mean, anthropology, there's great classes, and for me, being in engineering, we have to produce our parts. So what anthropology does is gives me an opportunity to actually do research. So I can study history, cultures, and Penn's full of various cultures. So it's just a wonderful opportunity to study anthropology.
Yeah, no, that's really interesting. I personally find that, you know, Penn, as many people consider it, is a work hard, play hard community, really. So a lot of people are focused on their studies as they should be. You know, it's an Ivy League school, but you have to make sure you're, I guess, strengthening your abilities as a human above just as an engineer or as a student. And also just have fun with it. You know, like you're in Philadelphia, like you don't always get 4 years in the city. In some cases, because of the pandemic, 3. So just go out of your way to, you know, meet people, try out new things, whether it be acting or joining clubs or whatever else it is.
Yeah, and speaking of people and fun, I can't help but wonder what type of community you think exists among the other staff members. You know, we've all met, you know, Peter Bruno, as well as I think Pete. There's another Pete. I forgot his last name, but
Doesn't-
yeah. What type of
Sesniak.
yes, yeah, yeah. What type of community exists among the entire technical staff? Could you that?
Well, I get just to speak of that, there's a camaraderie. Like
Yeah.
we do, like everyone has each other's back. So the main goal is the students, and that's our main focus. So if there's a student in need, we each have our own skill set that complements each other. So, and especially in my situation, without speaking to anyone else's, I'm here between 2 and 10 at night. So I'm here for that off-peak time when students are engaged in their studies, and that actually complements what's going on during the day. So, and that's where my colleagues are there to help and aid students in their issues and engineering problems. You know.
Yeah, I've taken
So,
advantage of the 10 o'clock cutoff before. And thank you very much. I remember there was one night where I had to work until 10. So
Yeah,
and it's a known, I mean, it's not quite known, but in the old days, maybe pre-COVID, maybe a few years before that, we used to run way over because, well, we needed to get things done. Right?
really,
Of course, that is not sanctioned by SEAS, but I'll throw that out there. We solve problems and the students come first, and that's me.
yeah, I remember I took MEAM 201 in spring 2019, and there was one night that I asked you for help, and you're like, "Sure, I can help you out. I just gotta get home by 10." You know, like my wife will be waiting at home. I want to make sure I get out on time. And then I looked at the clock and it was like 10:15, and I'm like, "Joe, like I'm so sorry, you can go." And you're like, "You know what? If you're willing to stay late, then so am I." And it's really that sense of, like you said, camaraderie. I'm sure it exists among the faculty, but also among the students with the faculty to kind of solve those problems together, even if it means maybe going over the posted time limits. But
Yes.
actually, you mentioned working with the students, and that's something we're curious to hear a little bit more about. Can you speak a little bit to, I'm sure this is a super broad topic, and as you said, one of your favorites, to how the experience is of working with students, you know, like what kinds of problems might arise that students come to you with, what kinds of emotions you feel on demo day for MEAM 201 at the end of each semester when you get to see all the hard work pay off. Like, just try and capture some of those emotions that go through your mind when you get to work with students and then see it pay off in the end.
Well, as you guys know, at the end of the semester, there's a heightened level of urgency. And when your urgency rises, so does mine. So, and I'm already hyper to begin with.
yeah,
As you can tell, I walk with a quick pace, and it isn't just the coffee. But I'm like when the students are in stressed and they have deliverables, these are the times when we band together, like the PML staff. We all join together, and it is more of a team effort. So some of the problems would be, you know, well, the easier ones to identify would be the manufacturing ones, being unsure, trying to hit tolerances on a lathe or a mill. So, and that's where I would just step in and kind of just say, all right, let's back up. If you're roughing out a part and you know you have like two or 300 thousandths to remove, the only time you have to worry is when you hit that tolerance. So you can quickly remove material, pick the right tools, and that's where I help guide you. But at that time, that's when the students are most stressed because they're performing tasks that they've only just learned from the beginning of the semester, you know, whatever it is, 12 to 16 weeks. So when the pressure gets amped up, the confidence goes down. And that's where I can come in and increase your ability to perform at a higher level, improve on your confidence. And then once I know you got it, I got it. So that's where the give and take is. And when I'm around the students, I feed off your energy. I may look older in the video. I'm a 60-year-old person that feels 40. So, and I can keep up with this.
I think it's really great that you mentioned the aspect of energy and how you feed off of it, because, I can say, for myself at least, that the difference between a lecture and a lab class or a hands-on class like MEAM 201 is I think the energy. I try to stay awake sometimes in lectures, no offense, and it's hard, and but I still enjoy it. But when I walk into 201, when I walk into PML, I have that energy. So I'm wondering, do you see any other differences between a lecture-based class versus hands-on? Because I'm also a tour guide for Penn, and what we always emphasize in talking about is the hands-on approach. And so what makes it hands-on, and what are the benefits with that from your perspective?
So the benefits are like twofold. I mean, fivefold. It's just like when you're sitting, and I myself have experience with that, sitting in a classroom and trying to stay awake at times, because it's a lot of theory based, nothing against theory, but like it's applying that in a hands-on aspect in a lab-based situation is invaluable. To apply to theory, and that's what MEAM does so well. I mean, the faculty just hit you with that theory, and then you're afforded the ability to get into a lab setting, and not just the precision machining laboratory, but even the ad lab and the laser cutting rooms and things like that. It's just that's some of the great benefits of MEAM and SEAS, and I think we have that over top all the other Ivies.
Yeah, I agree.
Penn is.
Yeah, I was just gonna say that Jason and I are in one class right now, or I guess it just wrapped up. MEAM 348, the junior and spring lab, and there's one lab where we had to study the heat transfer for keeping vaccine vials cool. And then in class we learned about like cylindrical coordinates, how heat transfer goes between surfaces like that. But then we actually get to run experiments, and create an Arduino circuit that has a thermistor that measures the temperature over time, and to see if we can actually simulate what we learned in class. So that was really exciting to do. But sorry I cut you off. Were you going to say something?
Oh, I was gonna make a similar point that it's really interesting in MEAM that it's so interdisciplinary, and you can pull from different areas, like you said, on the electronic side, Arduino, on the heat transfer side, like radiation convection, and then also like on the thermodynamic side. For listeners who might not be familiar, MEAM 201, which is the class we met Joe at originally, has an end of the semester deliverable, which is a Stirling engine, which obviously has a lot of mechanical machining and design that goes into it. But at the end of the day, you have to also understand the underlying thermodynamic principles, which is a whole different section of mechanical engineering that's integrated smoothly into that same product. And I think that is something about Penn and about SEAS and about mechanical engineering specifically that is really rewarding for students, that they can see it all come together. And it's the hands-on experience when they can really see it in action, see even the theory that they learned from a class like thermodynamics with Igor Bargadin and just all the other skills really coming to life. And Joe, it sounded like you were starting to say something a second ago.
Yeah, and I was just thinking, I actually had a student, well, he's not a student yet, but a young individual reached out to me that just got accepted to SEAS. Mm-hmm. And I think he's doing electrical engineering, but he loves mechanical. And he's actually on the team that I co-founded, or I was a part of, with Terry Kentz from Pennovations. And the first robotics team was Velocity. And here, this student is a member of Velocity, and he reached out to me. And as he's trying to overcome his fear of SEAS, of an Ivy League engineering situation. And I just said, hey, just relax. And I gave him some information about what teams did and to look into, Penn Electric Racing. And I just said, if you're in the area, stop in and I'll give you a tour. Of course, after COVID's done, we could do this. We can't do it during COVID. And I think it's just a good idea for anyone watching the video. Like, the minute you think you can't do it, that's going to be your most self-destructive thoughts.
Yeah.
Just believe in yourself. Anything's possible. I would have never thought I'd be here helping Penn engineering students as a machinist in manufacturing 30 plus years. And there's one thing I always thought was, I can do anything. It's just, I got to try, you know? But the fact that this young person reached out to me, and then we've corresponded a couple times, and this just happened in the last month. So I would advise anybody interested in engineering, don't hesitate. You know, the sky's the limit.
Yeah, that is a really good point. And I think I've learned a lot so far in just these 4 quick years or 3 years at Penn about taking initiative. And so I'm curious, you know, as like parting words, advice for students that are listening, you know, what qualities do you think you see in the most successful MEAM graduates? And maybe one of them is taking initiative, but what are some other qualities that you've been able to observe in your several years at Penn?
Well, I would have to focus on just the individual personalities. It isn't so much engineering, but the quality of the individual, the compassion. Like if you're interested in engineering, you could be a great engineer. I hate to say this, but an awful person. It has to do with individuality and being compassionate towards others. The qualities that you bring into Penn will get enhanced. So if you come in as a compassionate person, a team player, I mean, that sounds so cliche, a team player, yeah, and you will go so much further, you know, and go that extra mile. As far as Penn students, I mean, there is so much drive here and initiative, and most Penn students, 99.9% are compassionate individuals, and they come in here, and that's what makes them successful, and Penn sees that, and that's how they get in. So, and I would advise you to be yourself and bring humor too, because the minute you come in contact with me, you gotta have humor. So. And that comes with compassion. And then engineering, it all comes natural, and everyone's successful. So.
Yeah, I just want to follow up on that point that, you know, you have to come in and believe in yourself. One of my favorite sayings is, if you don't believe in yourself, nobody else will, which I think is really true. You know, if you come in not confident in yourself, you know, not willing to take advantage of the resources available to you, then nobody's going to do the work for you. But all you have to do is be confident. You know, I think one of the biggest pitfalls for students is what's called the imposter syndrome, where everybody at Penn, also at Penn, a similar thing called like Penn face, I think, where a lot of people think like, wow, I'm at Penn, everybody else is, you know, super smart and smarter than me, and like I'm probably just here by a fluke or something like that. But in reality, if you're here, you deserve to be here, you know, and people really have to keep that in mind. So you know, just make sure that you proceed through this education with that confidence, and also like you had talked about earlier, know what resources are available to you, and don't be too shy to take advantage of them. You know, I mentioned that like as Adam and I were going through looking for jobs, it's always important to reach out to people. Like, don't be afraid to ask for help, because people like Joe and a ton of other faculty at Penn are always there willing to give it to you. And then don't be afraid to give help. You know, if somebody asks you for help, be happy to return the favor and kind of pass it down from one generation of engineers to the next. So really just, you know, be confident and be resourceful, and then the rest will follow from there. Working with other people as well is obviously key to any successful group projects, and also just helping to learn from people, you know, teach people. Some of these key skills really are just so central to engineering that, as you said, some of the best engineers aren't the best people, and then they're not the best, most successful people in terms of what they're able to do, because it really just combines the technical skills with the social skills and being able to be confident, be motivated. So those are just
Yeah.
some of my insights, which I think are pretty much just echoing a lot of what you guys have said before. But yeah, that's all I have for now. I'll open it up to any closing thoughts that either of you might have, and then I think we're coming up on a little over half an hour here. So if
Well,
there are no
I can
closing thoughts,
add one thing, and I was thinking about it, and this has less to do with engineering, but my favorite question at night when I least expect it is, Joe, can we talk?
Yeah.
And I just light up. Sure, come on in. Let's sit down and let's talk about it. And those are some of my favorite conversations because most of the time they have nothing to do with engineering. So just know that my door is always open. If you're interested to come into SEAS, my email address is bjoseph@seas.upenn.edu.
Yeah,
My
I think
door's open.
you said it really well. Professors here and faculty and staff like yourself, they really break down those walls, and they're not seen as teachers anymore. They're seen as friends and as mentors, which on top of teaching is I think more important. And I think what, like you said before, it separates Penn from our peer institutions. So I'm just happy that I've been able to get to know you really well. And as me and Jason enter our senior year, we're coming short on the amount of time that we'll be able to have with you, but we're going to cherish every moment.
Well, you guys know I love you. So.
well, Joe. I think on that note, thank you so much to the listeners for viewing and tuning into today's episode. We were fortunate enough to be joined by Joe Valdez. Thank you again, Joe, so much for being here with us. I think I can speak for myself and everybody here that we couldn't be more appreciative for the time you spent talking with us and the insights and pieces of advice that you've given about going through this oftentimes intimidating time of our lives that we're currently going through, especially with COVID and all. So thank you. And again, I'm Jason Friedman. I'm joined by Adam Liang, and we're signing off until next time.